In the next set of videos, starting from this one, we'll be talking about transformations of the complex plane. And in this first video, under that, we'll be looking at translation. So how do we talk about how does translation look like in the complex plane? So let's go for it. Transformations of the complex plane, talking about translation in very simple terms, the transformation we are looking at here is that of translation, which means you have Z shifting from you have Z becoming Z plus A, right? Oh, okay. I think there's a repetition here. I think I can let go of this. So you just have Z becoming Z plus A. Then in 11.1, the definition. So if you let Z be X plus IY, that's the original complex number we know. And you now have a new complex number, which is defined as P plus IQ, which is a translation constant now. Then the transformation can then be said to be Z prime. So we have a new complex number, which is the combination of Z and A together. And if you substitute, right, it means Z prime is Z, which is X plus IY, plus A, which is P plus IQ. So if you collect like terms, that's real numbers and complex numbers collected separately. So you have X plus P for the real part, and for the imaginary part, you have Y plus Q. So at the end of the day, Z prime is X plus P plus I plus YQ. So X has shifted by P, and the original X is here, so it has shifted by by a factor P to the right, and then Y has shifted by a factor Q up. you know if you want to look visualize that on a graph, so it's more like you have this you have this is X here, and then this is, say, Y. So the coordinates, you have this. So this is actually Z now. But then with that P plus IQ, so for, let's say, um so this is already X, right? Let's now imagine this P is now here. See what the distance looks like. And then you have Q here. So being added to Y like that. So let's say it brings it up to this point, and then this comes up to this point. So we have the whole thing moving to this particular place. So from this point now we have a translation up to this point, and this is our Z prime. So now this is X plus P, comma Y plus Q. So it moves P to the right and Q up like that. This is the origin. This is X-axis. This is Y-axis. So that kind of thing. So we can then explain this. The geometric interpretation, like I've said just now, the transformation Z moving to Z plus A corresponds to X comma Y, which becomes X plus P. So you have a shift P, and Y plus Q, a shift Q. So this means there's a shift right by P. So if it was negative, it would have been shift left by P. But this is a shift right by P because it's an addition. Then you have a uh, shift up by Q. So from Y you move you move Q steps up. So it is now a translation, which you can call it vector shift in the plane, as I've demonstrated on that graph. So properties of translation: number one, distances are preserved, angles are preserved. So as you can see now, so the distances are preserved, and if you still if this continues, so this angle remains the same, and then the distances are also preserved, angles are preserved, shape is unchanged, as you can see, then orientation is unchanged also, parallel lines remain parallel. So if you shift a particular plane shape by the same factors, so everything remains in the same orientation, distances preserved, angles preserved, shape unchanged, and the parallel lines remain parallel. Like if you are shifting a cube or a keyboard or something. So translation is a rigid transformation, and it is in that case you can talk about isometry. Isometry. So let's talk about like this is saying that a translation is a rigid transformation, isometry. Everything is preserved as much as possible. So look at example one. You have 2 plus 3i, and then a is 1 plus I. So z prime now is z plus a. That means 2 plus 1. So you have 2 plus 3i plus I minus 1. So 2 plus 3, 1 is 3. 3i minus I, that's 2i. So the point moves from 2, 3 to 3, 2, right? So like I said, you can even demonstrate using Desmos. Though it is Des though it basically follows the Cartesian coordinate system, but then for complex number, we're talking about Argand diagram. So it's about the same thing technically. So imagine that we are moving from 2, 3 to 3, 2. So you have 2, 3, 2, comma 3, as you can see this here. And then you have 3, comma 2, 3, comma 2. So you see, so it has been moved some steps. This is where it was before. So it has been moved like 2 steps to the right, but then 2 steps down. And that's because there's probably a negative part here. So on the y-axis now we have it's moved 1 step down. So this is moved 1 step up. I mean 1 step to the right, then 1 step down like that. Okay. So yeah, this like one. So 1 step positive, then 1 step down like that. So that's what we have in that case. All right, so example two now you have a equals 2 plus I and z1 is 1 plus I, z2 is minus 2 plus 3i. So if you want to do zi prime, that's I mean z1 prime, that's z1 plus a. That's 1 plus I plus 2 plus I. That's 1 plus 2, 3, I plus I, 2i. Then z2 prime, that's z2 plus a. So z2 is minus 2 plus 3i plus a, that's 2 plus I. So minus 2 plus 2 is 0, and then 3i plus I, 4i. So now Zi, Z1 shifts from 1 plus 1 to 3 plus 2. So it moves 2 steps up, I mean 2 steps to the right, and then 1 step up on the y-axis. Then for Z2 now, the original Z2 is minus 2 plus 3i. So minus 2 plus 2, that means you move 2 steps to the right, and then you have 1 step up like that. That's what example 2 shows us. Now let's talk about translation of a shape. So if you have triangle vertices, Z1 is 0, Z2 is 1, and Z3 is I. If you want to translate by a, which is 2 plus 3i, then the new vertices will just be 0 plus 2 plus 3i. That'll be 2 plus 3i. Then for z2 now you have 1 plus 2 plus 3i, that's 3 plus 3i. Then z3 is I, that's 2 plus 3i plus I, that's 2 plus 4i. So the triangle keeps its shape and size, but then you have that movement, all the movements have been done like that. So we come to function representation. Translation can be written as a function t sub a of z, which is z plus a. That means you're moving a particular complex number z by a factor a. So this represents a mapping from the complex plane to itself. And then we move on to composition of translation. So it's possible to compose translation. So you can have a translation of a translation. So let t of z of sub a be equal to z plus a, and t of z sub b be z plus b. That means this means you're moving z by a factor a, and you're moving z in this case by a factor b. So t of b of t of a of T sub b of T sub a of z means that you are taking a translation of the translation of a. So T of z of a itself already, is z plus a, right? Then T of b is already z plus t of b is z plus b. So I think it's easier to write it if I write it but probably that will make more sense for easier understanding. So it's more like composition of functions. So you have t of a of z, which is z plus a, and then you have t sub b of z to be z plus b. And now we want to deal with T sub B of T sub A of Z. So what it simply means is that, of course, this is T of B composed with T of A of Z. So that means that we have, um, so first of all, that means what is T of B itself? T of B is Z plus B, right? That is what T of B is. But in place of, T of Z of B, T sub B of Z means that uh you have z plus b, but t of b of t of So it means that wherever you had Z, normally Z is there. So instead of having Z, now you now put T of A of Z in the place of Z. So that's why I wrote this as blank. So Z plus B normally. So T sub B of T sub A of Z, then it means whatever T of A sub Z is, which is Z plus A, we'll put it here. And then we finally have Z plus A plus B. So that is composition of that. That is T of B of T sub A. That is Z plus A plus B like that. So you can compose translations like that. Oh, okay, and then that's a sweet way of writing that, which is T sub A plus B. Okay, so we have that, and then we go for inverse transformation. So if you're given Z prime to be Z plus A, then the original Z is Z prime minus A. So it means you can recover your Z back by just subtracting A from the translated complex number. So the inverse then will be T sub A inverse, that is equal to T sub minus A, basically. Um, so now the question is, what is the effect on lines? If a line is imaginary of Z, which is equal to C, then after translation, imaginary of Z prime will simply be that C now plus imaginary of A. Then the line remains parallel. Then we talk about effect on circles now. So if you have a circle, absolute value of Z minus Z naught equals R, that's a circle whose center is at Z naught, you know, um, with radius R. So after translation, you have Z prime equals Z plus A. And then so you then have the circle to be newly Z prime minus Z naught plus A. And that is equal to R. So the radius stays the same, but the center will have to shift like that. So we can represent that here. We can show the translation of certain point here. So visualization of translation in the complex plane. So if you import number as numpy, matplotlib as pipe as matplotlib.pyplot as plot for visualization. So imagine points you want to visualize. That's 1 plus ij minus 2 plus 3j, 2 minus ij. Then the translation constant is a, which is 2 plus 1j. I wonder why I keep calling this one ij. 1 plus j, 1j. Then a is the translation constant, which is 2 plus 1j. So we are going to add this to all the components now. So this is going to be 3 plus 2j. This is going to be 0 plus 4j. This is going to be 4 plus that'll be 4 because 1j minus j is 0. So by the time we are done doing all of this, we end up having, so 2 plus 3j gets translated to 4j. I think that's the last one. Then 1 plus 1j, it becomes 3 plus 2j. And then we have 2 minus 1j becoming 4 plus 0j, like that. So yeah, with that, we come to we are done with that, but then we have practice problems. So I'm going to solve two of these practice problems, but let's go through the questions first. To find the image of z equals 3 plus 4i under z equals 2 plus 2 minus I. Of course, that's simply going to be, just put up z here. So you're going to have 5 plus 3j. That'll be the image in that translation. Okay. Then for find the image of z equals minus 2 plus 5i, we're under z being mapped to z plus 1 minus 1 plus 3i. So just bring this one down. That's minus 2 minus 1. That's minus 3. Then 5i plus 3i, 8j. 8i rather. That's minus 3 plus 8i. Like that. Then for question 3, so you have so for question 3 now, if z prime if z prime is equal to z plus 4 plus 2i, right? Find z prime when z is equal to minus 3 minus I. So that means you're going to take this away from z prime and you get your z. Or basically fix up z here and you get your z prime. So it's just like that. Um, Let me see the ones I'll be solving here. Hmm, okay. So So these are the problems we have going on in all of these places. So I'll take a couple of them and solve, and then we get it moving like that. So let me select the ones to solve. Just a minute. Mm, okay, I think I'll just pick anyone randomly and just get going. Okay, let me look around. Okay, I think I'm gonna take question 18. I'll take question 18. Then I'll also let me take an earlier question too. Find the translation vector that maps -1 plus I to 2 plus 4i. Okay, so I think I like this. So here now we just need to extract all the things. How did I used to do that? I think I'll need to snip, right? I'll take a snip of this. So question 10, and I just copy and take it over here. Yeah, so then I paste. So the question is find the translation vector that maps uh -1. So generally speaking, we know Z is mapped to Z plus A. That's the general idea we have there. So that means that Z here is -1 plus I, and uh Z plus A, which is actually Z prime. So that's Z, right? So that means Z prime is equal to Z plus A, and all of that is equal to 2 plus 4i. So what that simply means is that that means Z prime implies that we have, of course, the Z itself is -1 plus I, and that is equal to -1 plus I plus A is equal to 2 plus 4i. So A here now will have to be 2 plus 1. If you transfer this one here, that's 2 plus 1, then plus 4i minus I. That is this I coming here. So that A now is 3 plus 3i. Okay, so the question says find the translation vector that maps -1 plus 1 to 2 plus 4, 2 plus 4i. So this is the translation. This will be the translation vector. So the translation vector, the translation vector is 3 plus 3i. All right. And the original thing was Z -1 plus I, right? Then I'll take the other question. I think I said I'll take question 18. Question 18. Um, okay, wow. What I did is just like the A question 18 is just like the one I just did now. So this one here we are expected to verify this. Okay, well, I think I'll go for 19 then to verify this. Okay. Forgot that I snip, not copy and paste. So I snip this rectangularly. So we'll come here, we'll paste. So we want to verify that the absolute value of Z1 minus Z2 equals absolute value of Z1 plus A minus Z2 plus A, given that Z1 is 1 plus I, Z2 is 3 plus 2I, and A is 2 minus I. So we want to verify that this statement is actually the same. So we start with absolute value of Z1 minus Z2. That is equal to absolute value of Z1. That's 1 plus I, that's Z1, minus Z2. Z2 is 3 plus 2I, like that. So that's equal to absolute value of 1 plus I minus 3 minus 2I. So That means 1 minus 3, that's minus 2. Then 1 minus 2i, that's minus I, right? Yeah. So then we can say this is the same thing as absolute value of minus 2 plus I, and that is equal to 2 plus I in all if you take absolute value. So that means that absolute value of Z1 minus Z2 is equal to 2 plus I. So that's the right hand side. So for the left hand side, which is this now, uh, let's see how that goes. So we then have absolute value of Z1 plus A minus Z2 plus A, like that. Yeah. So this is equal to absolute value of Z1. Z1 is 1 plus I. So that's 1 plus I plus A. A is 2 minus I. 2 minus I. So that's the first part. The minus Z2. Z2 is 3 plus 2I. 3 plus 2I plus A. A again is 2 minus I. So absolute value of that. So we try to tidy things up here. So we have absolute value of 1 plus I plus 2 minus I minus 3 plus 2I plus 2 minus I. So this is equal to absolute value of 1 plus 2, 3. I cancels I easily. Minus inside there we have 3 plus 2, 5. 2I minus I, that's plus I. Okay. And then this is 3 minus 5 minus I. Then 3 minus 5 is minus 2 minus I. Then we can factorize like before. That's absolute value of minus 2 plus I. And then that is still the same thing as 2 plus I that we got before, like this. And then we can say, so the absolute value of Z1 plus A minus Z2 plus A is simply the same thing as absolute value of Z1 minus Z2, like that. So with that, we come to the end of this interesting video on transformations in the complex plane, with focus on translation, and translation being changing from Z to Z plus A by a transformation, what we call a transformation factor A, like that. So let me know how helpful this is for you. And if there's something else like in the trials, feel very free to let me know. Don't forget to try your hands on the practice problems. I have 1 to 3 questions, 1 to 3 here, then 4 to 7, 4 to 7 like this, then 8 to let's say 8 to 10. I think I answered 10, right? Then 11 to 13, 14 to 16, 17 to 19. Okay, then I just show 18 to 20. So yeah, if you have subscribed to this channel already, thank you very much for doing that. If you have not subscribed, why not go ahead and do that right away and hit the notification bell so you can always get alerted each time a new video is released. Having done that, you can also become a member of the channel by clicking on join. That gives you special privileges like getting to see some videos first or seeing some videos exclusively as a member of the channel. Okay, you can request for PDF copies of my notes. You can also hang out with me online or physically if you're ever in the same geographical location. Ultimately, don't forget to comment, like, share so that more people can have access to the great content I have going on here. Till I come your way again, keep doing maths right. Bye.